Good evening, everyone. Thank you for joining me. I am Mr. Ish. I had this request from a viewer to solve this out. A question from their class, from their course. A power series question they wanted solved out. N equals 1 up to infinity. We have n divided by b to the power of n times x minus a to the power of n. The b here is a positive value larger than 0. You have a lot of letters over here, but don't get confused by them. You know the main items here are really n and x. Everything else is just think of it as a bonus. How do you go about solving something like this? Always think about the ratio test. You have your a n plus 1 term. What will that be? Wherever you have n, you put n plus 1. You'll have n plus 1 divided by b to the power of n plus 1 times x minus a to the power of n plus 1. Then you have this a nth term. The original function is exactly that, n divided by b to the power of n times x minus a to the power of n. You can do all of this in terms of a ratio and just bring absolute value, and you've set it up already. Open everything here using your algebra, your laws of exponents, all of that. You'll have n plus 1 divided by b to the n, b to the 1 times x minus a to the power of n, x minus a to the power of 1. The denominator is not going to generate much other than what you already have. N divided by b to the n. You have x minus a to the power of n. All of this in absolute value. Cancel your like terms. This cancels out with that. That cancels out with this. What remains is x minus a divided by b, and then you have n plus 1 divided by n. You can put all of that. All of this is multiplying with each other. But you still have to do your limit evaluation, don't you? Limit as n approaches infinity. We're only looking at this part right here, n plus 1 divided by n. All of this will equal to a 1, but this 1 will multiply with this. You'll really end up having just x minus a in absolute value divided by b. That's exactly what comes out of all of that, the ratio test. You know, when you're doing the ratio test, the items less than 1 gives you convergence. You evaluate everything based on that. X minus a absolute value is less than b. You take this on the other side. What does that b give you? It gives you your radius of convergence. This value right here is my radius of convergence, and it's equal to a b. The radius of convergence represents your b. It represents your spread. With regards to your possible x values that will give you convergence, I'll tell you how much to the right and left of those values in terms of that extent of that b is leading to convergence. We have a case over here where select values will give you a convergence when those values are placed in position of x. It's not a case where you have only a single value in terms of convergence, or where you have infinite number of values of convergence. We have your type 3 case of power series, the type 3 case where you have these type of finite intervals of convergence develop. You have to solve this out. Solve this out by means of an inequality. You open it up. X minus a is less than b. X minus a is greater than minus b. X here is less than a plus b. X over here is greater than a minus b. That tells you your interval of convergence is this. X is less than a plus b, but it's greater than a minus b. But we don't know if this is our finalized interval, because we don't know if these equal signs should come over here or if the inequality stands as is. We have to test these values out, these endpoint values in our original function in place of x. Then that will narrow things down for us, and our interval of convergence will then be finalized. The two values which have to be tested out in places of x are this. You have a minus b, and then you have a plus b. You have to test those out. You'll test them out right here in place of x in your function. N divided by b to the n. You're looking here at a minus b minus a to the power of n. You know you're looking at n equals 1 up to infinity. Plug in the other ones. You're looking here from n equals 1 up to infinity. You have n divided by b to the power of n. You have a plus b minus a to the power of n. Let's simplify this out. The a's will cancel out. You're really looking at minus b to the power of n. Here the a's will cancel out. You're looking at b to the power of n. Here you're just looking at minus b to the power of n. Here you're looking at positive b to the power of n. Now you have to solve this out to see if you have divergence or convergence. You can use a basic test. If you were to look at this entire function in terms of the limit as n approaches infinity, would your series an zero out, or it would not zero out? Then you can figure it out based on that, and you don't have to do anything more complicated than that. So let's do that. Let's look right over here. You have limit as n approaches infinity. You have n divided by b to the n times b to the n, but these cancel out. It's really looking at just n. You put right over here and you're going to see your infinity, and this right here is a divergent case. So this inequality will stand exactly as is. There's no equal sign coming into play. So this part right here has been done. Let's evaluate this. You're looking at limit as n approaches infinity. You have n divided by b to the power of n times minus 1 times b to the power of n. You can separate these into their individual exponents. I'm just doing algebraic manipulation to help iron it out. This cancels out. All I'm really left here with, let's put it right here. Here's n times minus 1 to the power of n. You have to evaluate that with regards to the limit. N times minus 1 to the power of n. You would put infinity here in places of n. You're really looking at infinity times minus 1 to the power of infinity. This certainly is not a case where you're tending towards 0. You are again here looking at a case of divergence. So that tells you these are inequalities which are good. Everything is exactly like that. Your values of x which will lead to convergence in this particular case are less than a plus b, whatever it might be, and greater than a minus b, whatever it might be. They don't include these values. Any values outside of this x, possible x values, are all divergent. Your radius of convergence over here, b, is good. From this value right here, in this direction of b, are all your possible values of x which are convergent. Hence I call that the spread, or your radius of convergence. This right here is your interval of convergence, and your answer is right. You can just put your answer like this. You have b, that represents your radius of convergence. Then you have a minus b is less than x, which is less than a plus b, your interval of convergence, and you're good. And verbalizing everything again, the possible values of x for this series which lead to convergence are less than a plus b but greater than a minus b, with a radius of convergence of b, and your answer has been done. That's all I want to present to you in this video. This question has been solved for that student. Thank you for watching. Have a good day.